Hello and welcome to Solving Systems of Equations Substitution Method. Yesterday in class we did graphing method. So we graphed two lines and we found out where they intersected, and their intersection was a point, an x comma y. So today we're going to talk about how we do this algebraically. Graphing has some limitations. So let's talk about a little bit of those limitations. So yesterday when you were graphing, if you didn't graph a straight line, it was hard to tell where the intersection was. If for some reason you graphed the line wrong, you couldn't tell where the intersection point was. If you accidentally did a negative slope instead of a positive slope, it was hard to find where that point of intersection was. But there's one more big, huge limitation that happens in graphing, and that is what happens if they don't intersect on a perfect coordinate, like this one. We're gonna guess. This might be like 2 1/4, comma, negative a third. I don't know. But that would be really hard to figure out where that exactly is crossing, and we'd have to do guess and check, guess and check, guess and check. And so graphing is very limited because if it doesn't cross at a perfect coordinate point, then we have to do a lot of guessing and checking, which, there's better ways to do things. And one of those better ways is by using the substitution method. So we have, pencil, write this down. We can find the solution of a systems of equations 3 ways. 1, graphing. That's what we did yesterday. 2, substitution. That's what we're going to do today. And then the third method that we're going to learn tomorrow is linear combination. So today we're going to just focus on substitution. So what does substitution mean? Well, here I am, and I am teaching, and yesterday and 2 days ago I was gone. So what happens when I'm gone? Somebody comes in, a substitute teacher comes in and replaces me. And so when they replace me, that's what substitute teachers do. I'm not here with the substitute, I'm gone. So when we talk about substitution, we talk about to replace. What does that mean? That means we take something and we replace it. Just like when I have a substitute teacher, they replace me. I'm not here with them. So let's do this first example. Solve by substitution. Y equals 7 minus 2x. 3x plus 3y equals 9. Here's 2 equations. This is systems of equations, and we are going to solve it by substitution. So the first thing is you want to make sure that one of the equations is isolated for a variable. And if you can see this, this is solved for y. Okay, we're going to take a little pause break here. I'm going to orientate my board here so that it draws a little bit nicer, and then I'll come back in a second. Okay, sorry about that. I had to get my board all straight so that it wouldn't make those funny curves. All right, so y equals 7 minus 2x. What we're going to do is we're going to take this part, just the 7 minus 2x, and we're going to substitute it in for the other equation where you see a y. Now I don't leave the y there. Remember, substitution means to replace. So I'm going to take that equation 3x plus 3, and in place of that y, I'm going to take that y out completely because it's substituting it in, and I'm going to replace it with 7 minus 2x. And I'm going to use parentheses because I'm replacing the whole thing, and that equals 9. Okay, and now I'm going to solve this. You can notice there's only one variable here, and so now I'm going to solve for that variable x. 3x plus 21 minus 6x equals 9. 3x minus 6x is negative 3x plus 21 equals 9. Subtract 21, negative 3x equals negative 12, x equals 4. Now remember, when we were doing this yesterday, we found the solution. The solution is where it intersects. That's an x and a y. We've only found x, so now we need to find y. So what I'm going to do is I'm going to take that x and I'm going to plug it back into the top equation and see what my y will be. So y equals 7 minus 2 times 4. Y equals 7 minus 8. Y equals negative 1. So the solution is 4, negative 1. But I should make sure that that works in both equations. I know it works in the top one because I just did that here. What I need to make sure is that it works in the bottom equation as well. So 3 times 4 plus 3 times negative 1, does that equal 9? So there's my question. I want to make sure it works in both equations, just like you did yesterday with graphing. 12 minus 3, is that 9? Yes, 9 equals 9. Therefore, the solution is 4, negative 1. Okay, let's do another example. Solve by substitution example number 2. Okay, well, when I look at this systems of equations, I don't notice that anything is solved for y. So now I'm going to have to do one of those steps that I didn't have to do in the last problem. So because there's a 1 in front of this y, I'm going to go ahead and solve this one, the first equation. I'm going to solve it for y, because that'll be the easiest one. Otherwise, I'm going to have fractions in the other one, and I don't want to work with fractions. I want to work with things that don't have fractions. So negative 4x minus y equals 2. Add 4x to both sides. Negative y equals 2 plus 4x. Divide by a negative 1. Divide everything by a negative 1. And I get y equals negative 2 minus 4x. Okay, there is my y equals equation. I'm going to take that negative 2 minus 4x, and I'm going to replace the y in the other equation. So that's the substitution method. 7x plus 2 times negative 2 minus 4x equals negative 5. I replace it. The y is not there anymore. Remember, when we substitute, we replace. And then I go ahead and solve for x. So 7x minus 4 minus 8x equals negative 5. 7x minus 8x is negative 1x minus 4 equals negative 5. Add 4 to both sides. I get negative 1. Divide by negative 1 on both sides, and I get x equals 1. Okay, that's only part of my answer. Remember, my solution has to have an x and a y. So now I know my x is 1, hopefully. And now I'm going to go back up to the original. Don't use the one that you solved for y for, because you always want to check it in your original. You always want to use originals when we're checking. We've done that every time. So let's go back to the original. Let's plug in the 1. Solve for y. Negative 4 minus y equals 2. Make sure my y looks like a y there. Add 4 to both sides. I get 6. Divide by negative 1, and I get negative 6. So there's my solution, hopefully. But because we're not sure, we're going to check it in the bottom equation as well and make sure that when I plug in x and y, it works for both. We know it works for the top one, so that's fine. Now we're going to do the bottom. 7 times 1 plus 2 times negative 6. Does that equal negative 5? That's always the question. 7 minus 12, does that equal negative 5? And so does negative 5 equal negative 5? Yes, it does. So that is my solution. All right, let's try one more. Sometimes strange things happen, just like strange things happen when you were graphing. On number 6, you realized that they were parallel and there was no solution because same slopes never touch. Okay, and then we also talked about the number 8 one on there, that it showed that they were the exact same line, and that's all solutions. So sometimes strange things do happen. So let's go ahead and see what happens on this one, because there is something strange that happens. I'm going to take this one, and instead of solving for y, I'm going to solve for that x, because the x has a 1 in front of it. And I always want to work with the variable that has a 1 in front of it, then I won't have any fractions. So let's go ahead and solve for x. Add 2y to both sides. I get 4 plus 2y. Now I'm not replacing the y, I'm replacing the x. So be careful with that. Whatever you did solve for, that's what you replace. So in this case, I'm replacing the x. So it's 3 times 4 plus 2y, parentheses, minus 6y equals 8. 12 plus 6y minus 6y equals 8. 12, 6y, negative 6y cancel. 12 equals 8. Is that true or false? So that's definitely false. 12 does not equal 8. So when this happens, the answer is no solution, because these graphs, what will be this graph? What do we know about this graph? What would it look like if we have a no solution? It will be parallel lines. They will never touch or cross. Okay? because they're parallel lines. So you could also get one that when you substitute back in, they cancel out and the numbers equal each other. And when the numbers equal each other, that's going to be an infinitely many solution. And that graph will look like one graph on top of the other. So just remember, substitution means to replace. We've talked about graphing and substitution now, and we'll see you tomorrow in class. Have a great day.